So looking at example 2, it's just another real-world example or a real-world problem. We've got a flagpole. It's supported by 2 guy wires, each attached to a peg in the ground 4 meters away from the flagpole. The guy wires have angles of elevation of 35 and 45. Remember, angle of elevation is from the horizon up. So this is an angle of 35, this is an angle of 45. So the guy wires that are attaching to this flagpole attach a little lower if you have the angle of elevation of 35 and a little bit higher if you have the angle of elevation of 45. The question that comes into play, it says, how much higher up the flagpole is the top guy wire attached, and how long is each guy wire? So it wants to know the distance here, right? From, let's undo that. From this point all the way down to this point. That's A, or question A. And then they also want to know how long are these triangles, or side lengths. We have to make an assumption, and we always make this assumption about flagpoles, trees, houses. They form 90 degrees with the ground. So if we have 90 degrees with the ground, and we have this long side length of 4, we can do a couple different things. Well, for A, to solve for this distance, how far apart they are, well, we really need to know how far up the flagpole is. So we're going to actually solve for the height of X and the height of Y, and to figure out the difference, we're going to subtract them. Okay? So with this smaller triangle, if we look here, this one, with the angle of 35, we have an angle of 35, we have side 4, that's adjacent to the angle, and this is the opposite side, so we're going to use tan. So tan of 35 equals x over 4, so 4 times the tan of 35, which turns out to be 2.8, so it's 2.8 high. The other triangle we're going to use for y is this bigger one with the angle of elevation of 45. It still has an adjacent side of 4 meters here, right? And we're looking for the opposite side, y. So we're going to do the same thing, but we're going to have tan of 45. Tan of 45 is equal to y over 4. We multiply by 4, we get y equals 4 meters. So we have 4 meters as the big one, and we have 2.8 meters as the small one. So the difference between them is 4 minus 2.8, or 1.2. So the top guy wire is 1.2 meters higher. Now if we come back to our picture, they also ask in part B, how long are these wires? Okay, well, if we look at this, this is really just another part of this triangle we were looking at. We solved for side length x. Now we can use angle of 35 and this 4 meters to solve for the hypotenuse. The hardest part is remembering that flagpoles, trees, houses, they make 90-degree angles with the ground. So side length A and side length B with a bigger triangle are hypotenuse. So it's going to be adjacent and hypotenuse. So cos. Cos of 35 is equal to 4 over A, and the cos of 45 is equal to 4 over B. So you'll see we just did the calculations here. Big thing, cos of 35 over 1. We cross multiply, we get 4 is equal to A times the cos of 35, and we'd have to divide by the cos of 35. So the one guide wire is 4.9 meters, and the other guide wire is cos of 45 equals 4 over B. We get rid of our B, divide by the cos of 45 is 5.7 meters. Okay, so the two guide wires are 4.9 and 5.7. So more pictures Remember the difference between angle of elevation and angle of depression. Depression, the angle of elevation is 45. The angle of depression is from the horizon down. So this guy, angle up, angle of elevation. This guy, horizon down, that's the angle of depression. Okay, so just remember the difference between angle of elevation and angle of depression. I know in your other Build Your Skills previously in this unit, it talked about the difference between those two terms. Okay, so good luck working on those Build Your Skills.